Hey folks, Nathan here. We're starting to get ready for our Aquarion flight computer, and the first thing that we need to test rigorously is our BMP280 Barometer. So this is what we're going to be using for our altimeter to know how high up the rocket's going. And in order to test it, we've built this small little circuit here. It looks like it's quite a mess because it's all breadboarded, but essentially it's a barometer, an SD card reader, and a light, and with that we can use it to log some data under various conditions and figure out how accurate our BMP280 is. So let's get into it. So this mess of wires here is our circuit. We have our Arduino here. Over here we have the BMP280, and up here this big thing is our SD card reader. Right now this is just built to work on my desk, so we're going to need to add a couple of things in order to let us go out into the real world and use it. So first thing we're going to need is a power source, which we're going to be using the 9-volt battery from the Hydron rocket. That still works pretty well, so we're just going to attach that into our breadboard here and use that to run everything. The second thing we're going to need is some sort of indicator lights so that we know what state this is in. Because if this fails, then we really want to know about it, because if we don't, we're just going to sit there for 5-10 minutes and just not get any data at all. So we're going to do that now. Alright, we're going to use paint to show our 4 states. So to start off with, we've got a box here. So state number 1, off. State number 2, SD fail. State number 3, BMP280 fail. And state number 4, business as usual. Alright, so let's do some planning here. This is going to be our light in all 4 cases. So business as usual, we're doing quite a lot of processing here, because every loop we're taking a reading, we're opening a file, putting it in and closing it, and ideally we want to have a good stream of data as we go. So for this reason, business as usual is going to be lit up at all times. So if the LED is lit flat, we know that business as usual. Off, pretty clear, no light, so don't need to worry about that. And then, cool. So our 2 indicators here now are SD card fail and BMP280 fail. So we've already got off and we've already got on, which means that we've got flashing for these 2. I think one of them we're going to have a quick flash and one of them will have a slow flash to differentiate. So let's say SD card fail. Fast flash, and BMP280 fail is slow flash. So from this we've got our 4 states that we need to represent with just 1 light. This is very nice, so let's go and do that in code. Okay, this here's our code. We're going to quickly go through it and explain what it all does, and then we're going to go and add our states in. So first of all, we have our includes up here. These deal with the SD card and with writing, reading data. Adafruit BMP280 is specifically for the 280. Wire.h is for dealing with IOC connections. We declare our variables. We have our BMP. We have our file that we're reading, writing to. We keep track of our current file path for reasons that we'll show later. We have a state for whether the sensor's active, our current read count, which is what we read into the file, and the current pressure, which is basically just our start pressure, and we use that to essentially figure out what our height offset is from our original. So, our setup, we initialize our SD card, program starts. Here we essentially just create our file, so we have a file index number that just iterates while the current file exists. So it's going to be 280 log 0 to start with. If that file exists, it goes 280 log 1, 280 log 2, etc. until there's an empty spot. And we create our file, we write our path, or write a file here. Here we have our initializing the sensor. So if the sensor fails, we give it a bit, and then we say the sensor is not active. If the sensor is active, we set it up, we start writing, If it's not active, then we go down here and we say the sensor's inactive and we exit the program. Our loop is pretty simple. All we need to do is say if the sensor isn't active, which we flagged up here, don't run the loop. And then otherwise we want to create a file with just the current read count, the current pressure in pascals, and the current altitude based on the start pressure that we set. And we close it, we set the read count +1, and it just keeps doing that until the Arduino is turned off. So that's nice and simple. Let's go in and set up our states. So set lighting state, we have an integer for the state. We have state of 0, it's nominal. State of 1 is SD failure. State of 2 is our BMP280 failure. Wonderful. So we want to do a switch statement. If it's 0, we just want, oh, we haven't set our pin up yet actually, we better do that. Okay. LED pin. Let's go up here. Okay, so we set up our pin mode, LED pin output. Wonderful. We've got that there. So now we can go down here. We want digital write LED pin. Hi. It's pretty easy. Case 1. We want, so for our, go back to paint. SD fail is a fast flash, BMP280 fail is a slow flash. So we're going to go for SD failure. Delay by, let's flash twice a second. Wonderful. And we're going to do that for 5 seconds so that we have the time to see what's up. I is less than 10, I plus plus, because we're this is a half-second loop, so we want our half-second loop to loop 10 times, and that's going to give us 5 seconds. Excellent. And break. Case 2, which is our SD card, our BMP280 failure. We essentially want to do the same thing, but we want to change our timings. So we want the high to be on for 750, up to 250, and 5. So we have our 5-second loop here for our states. And chuck a default in as well, just so it's all cases are considered. Right. So you want to go, what's our class called? Set lighting state 1 for SD card, 2 for BMP280, and we just want 0 for our here. Phenomenal. Alright, looking at our circuit, we're gonna chuck the pin on 7 for the light. Excellent. So let's chuck that on and take a look at how it goes. Okay, this here's our circuit. Our light is here. So this is what's going to flash. So let's simulate a few different conditions. So first of all, right off the bat, our SD card is not plugged in, as you can see. So we're going to simulate that failing. Reset our Arduino. And there's our quick flashes showing that the SD card is not currently set up right. So let's pull our SD card out of here, chuck it back in here, and then hit run or hit reset. And we can see that's all working normally. Alright, so next up, we're going to simulate a BMP280 failure. Now let's reset and see what happens. There's our long flashes showing that the BMP280 isn't registering. So that is all working as intended by the look of it. So yeah, our circuit here is complete. We have our 9-volt battery, we have our actual circuit. If we turn it on, it's now logging data. And then we can turn it off, and it's not logging data, which is wonderful. To test things out, we're going to run 3 different tests here in our house. So the first one is going to be testing it with no wind at all, just purely stationary sitting on the desk. The second will be me just blowing on it every now and then just to see if that registers at all. And the third will be holding it in front of a fan to see just how much variance that adds. Test number 1, 30 seconds of stationary air in 3, 2, 1, go. And stop. Test number 2 will be 30 seconds of random blowing on the BMP280. Starting in 3, 2, 1, go. And stop. And for test number 3, we'll be holding it in front of this fan. So, we might mute this, we'll see how we go. Starting in 3, 2, 1. Stop. You can see our 3 files in here. So number 1 is our stationary test. We can see that the number or the pressure isn't really changing much. Number 2 is our blowing on it test, where the pressure is going up a little bit, but not a huge amount. And our third is the fan test, where we're also getting some changes, but once again, not a huge amount, but our numbers are definitely big there. Okay, so let's bring these into Google Sheets and see what we've got. Okay, we've got ourselves a new spreadsheet. What we're going to do is open up this one. We want to copy. I'm just going to do a Control A for copy all. So sheets. We're going to clear this data because it's not relevant. Then we're going to go data. Let's split to columns. And it automatically sets it up for us. And there's our data. So we're going to have this sheet here, which is static. We're going to have two new sheets. One is going to be blowing, and one is going to be fan. So I've gone ahead and done all the graphs. So we can see here that with static, the pressure is pretty consistent. There's a little bit of variation, and as that pressure rises, our altitude thinks that it's going down. So we can see that just in a static room we have a good variation of roughly 1.25 meters at most, maybe 1.5 to be safe. If we go to blowing, we can see that it's a bit more erratic where the blowing was happening. And that's also led to some pretty erratic curves here. Once again, even with the blowing, we're at about 1.5 meters of variance, probably stretching towards 2 if we want to be safe. And then looking at the fan, we have our pressure dropping significantly when the fan goes over it, so we can almost see the fan cycles here. And that's giving us a pressure increase of almost 2 meters. So this will be a good 3 meter variance. So this is, yeah, just with a fan blowing on it, that's a 3 meter variance. And on a windy day, that could be a lot more. So I think we'll probably go with a sort of 5 meter variance, I'd say, just to be absolutely safe with all of our calculations here. So if we assume an error rate of 5 meters, then that gives us a good baseline for our flight computer. And here we have all 3 graphs together, just so you can see the difference between them all. And that's about it for this one. So we've learned that the BMP280 has quite a bit more variance than I was expecting. Just in a static room, we're getting almost 2 meters of variance in there. So that's something that's going to have to be accounted for when we do our coding for the flight computer. And yeah, if any of you are using barometers or looking to get into building your own flight computer, this is definitely something that you're going to have to keep in mind, because if you just assume that it's giving you accurate readings all the time, you're going to get things like fake launch detection, bad apogee detection, and you might just have a complete failure of a launch. So yeah, that's something fun to keep in mind. Catch you in the next one.